Okay, our third example is x cubed plus x squared is less than or equal to 4x plus 4. What makes this one interesting is there's going to be a decent amount of algebra here, but one thing we haven't covered is what if there's more than two boundaries? In this case, we're actually going to end up with a third boundary point, and we're going to have to see that we're going to have more sections to check, and it won't be as easy because one of those sections is going to have some fractional values that we're going to have to deal with. Let's see what we're talking about here. So in order to do this, like every one of the problems we did before, we have to set one side equal to 0. So again, I'm going to keep the x cubed that I already have positive. I'm going to keep it there. We're going to move the 4x and the 4 to the left-hand side. So we're going to have x cubed plus x squared. We're going to have to subtract 4x and subtract 4 from both sides so that I get minus 4x minus 4 is less than or equal to 0. Now, if you remember how to do this, when we have 4 terms, we don't have anything in common in all 4 terms, so the easiest thing to do is to look to factor this thing by grouping. So when we factor it by grouping, I'm going to take the x cubed plus x squared, and I'm going to take the minus 4x and minus 4, and we're going to group those so that they're in groups. But notice what I'm missing in between the two parentheses there is that I'm missing a sign of some kind. This looks like multiplication. This is not a multiplication problem. So I have to make sure that I put an addition symbol in there because I'm really adding those. You can't chop off that negative sign in front of the negative 4x because otherwise this isn't going to work and you're actually losing the sign of the 4x. The 4x is a negative, so it has to go in the grouping with there. So now we're going to take out the common factor from each one of these parentheses. The greatest common factor in the first grouping is x squared. So if I factor out x squared, that's going to leave us with x, not x squared. That's going to leave us with x plus 1. In the second grouping, it looks like I can take out a 4, but I want to take out a negative 4 because what I'm trying to do is get each one of the parentheses to be identical. So if I take out a negative 4, now if I take out the negative 4, that leaves me with an x and then a plus 1, which is good because I really wanted these two things to be exactly the same. Because now what I can do is I can factor out the x plus 1 from each one of those, and when I do that, what that's going to leave us with is this x squared and that minus 4, and that's going to go in my second parentheses. Okay, the x plus 1 in the step above was the greatest common factor now. I factored it out, and that leaves us with x squared minus 4. I've got one more thing to factor. The x squared minus 4 is a difference of squares, so we can go ahead and factor that to x minus 2, x plus 2. And now what you should be able to see is now I have 3 values that I'm going to have for boundary points. I'm not going to set each one of those equal to 0. I'm hoping that you can intuitively see. In the first one, it would be x equals negative 1. In the second one, it would be x equals 2. And the third one would be x equals negative 2. All of those things would make the parentheses equal to 0. So that would be our boundary points in this case. So let's go ahead and set up our number line. Let's go ahead and do that over here. Remember, these have to be numerically in the correct place. So negative 2 is the least amount, negative 1 is next, and then 2 is next. I did not write the I did not write my tick marks in a numerically it's numerically in the correct order. I just didn't space them out the correct way, and it doesn't really have to be spaced the correct way in order to do what we're doing. We're just checking the regions. But what you should notice now is that I have 4 regions. I have that region, that region, that region, and that region. I've got 4 different regions now to check. So we're going to check all 4 regions and see what happens. Let's do one to the left. I almost always go left to right, but you don't have to. You can go in any order as long as you don't forget to check one of your regions. I start with the left, so anything left of negative 2, like negative 3. Now, if you have this kind of form, if you have what we have here, if we have a factored form like we do right here, I always use the factored form. To me, it's just easier. If I were to plug negative 3 into the first parentheses, I would get out a negative 2. If I was to plug negative 3 into the second parentheses, I would get out a negative 5. And if I were to plug a negative 3 into the third parentheses, I would get out a negative 1. Okay, you can obviously multiply all those together, but ultimately what you're looking for is you want something to be less than or equal to 0. Well, if I have three negative numbers multiplied together, three negatives times each other are going to give me a negative. It's going to be a negative value. So this one definitely will be less than 0. I'll go ahead and multiply these out anyway. It's going to be negative 10 is less than or equal to 0. But if you could see that all of this was just going to give you a negative value, then you don't have to necessarily give me the number. I'm not concerned with the fact that that was negative 10 as much as I'm concerned with the fact that it was negative. All right, what did we want? We wanted this to be negative, so that's a good section. I like that one. That works. Let's check something in between -2 and -1. Now this is where I was talking about you don't have to necessarily multiply or add and subtract these numbers out. What you really need to do is you need to figure out what the sign of each parentheses is. That's where the most important one is. So the first one where I had the x plus 1, then I had the x minus 2, then we have the x plus 2. We want to see if this is less than or equal to 0. If I plug something in between -1 and -2, and now I'm dealing with fractions. Now granted, you can use your calculator to do this if you want to, but if you didn't have a calculator and just needed to do it quickly mentally, again, I don't care what the values are so much. If I were to plug a -1/2 into this parentheses, this first parentheses right here, this one right here, -1/2 plus 1, well, 1 is bigger, so that's going to be a positive value. That's all I really need to know is that that's positive. If I plug a -1/2 in here, -1/2 minus 2 is more negative than it was to start with, so that's still negative. And then if I were to plug -1/2 in here, -1/2 plus 2, 2 is bigger, so that's going to be a positive value. So what I have here is I have two positive values times a negative value. Well, two positives times a negative means that we're going to end up with a negative value. So this is going to be some kind of a negative, which of course is going to be less than 0, less than or equal to 0. So that is also a good section. I like that one. Okay, I'm happy with that section. All right, let's check the next section. Let's check anything in between -1 and 2. The easiest thing to pick is 0. So again, I'm just going to use the parentheses method here. If I were to take 0 and I were to plug it in to all of these, 0 plus 1 is positive, 0 minus 2 is negative, oops, -2, I didn't need to write the 2, and then 0 plus 2 is positive. So here I'm going to get two positives and a negative, which is also going to be negative, which means that that is less than 0, so that is a good section. And for some reason, I think I've made a mistake somewhere here. Where did I make my mistake? Maybe not. I'll come back to it in a second. I have to go through and look at this again. For some reason, I'm thinking the one in between -1 and -2 shouldn't have worked. What did? Oh, I said -1/2. It should have been -1.5. That was silly of me. All right, so I'm going to have to fix that, and I apologize. So this, oops, this is not correct down here. Let's go ahead and erase these. I apologize for that. If we go back and look at this again, it should be -1.5, not -0.5. -1.5 in the first parentheses is going to be negative. Oops, let's try and write with a pen. There we go. Is going to be negative. -1.5 minus 2 is also still negative, but -1.5 plus 2 is positive. So here I get two negatives times a positive. Two negatives make a positive times another positive is still positive, so that's bad. I thought something was wrong there, so that's a bad section. I don't like that one. And you might have already been able to guess, but we probably will end up with a bad section for the last one, but let's check it out anyway. So again, I'm just going to do my three parentheses. Hopefully I won't make that mistake on this one. So if I plug something bigger than 2, if I plug something bigger than 2 into the first parentheses, that's positive. If I plug something bigger than 2, like 3, into the second parentheses, that's also positive. And then the last one is also positive. That gives me a positive value. That is false. I do not want that one. So these were false statements. So that's out. Okay, let's make sure that we're looking at this because, again, remember this thing had an equal to symbol on it. I only want the ones that were less than or equal to, so it means I have to include my boundary points. You can never include an infinity, so make sure you remember that. So the first section is that one to the left, which says that negative infinity up to negative 2 is my first section. I can never include the negative infinity, it gets a parentheses, but I'm going to include the 2. My next section is in between negative 1 and 2. Both of those are boundary points, so I include both of them. And this is the solution. So again, I apologize for that little mistake there. Hopefully you caught it before I did, because I knew that something wasn't right there. Didn't look right. I was using the wrong boundary. I was using the wrong test point. All right, one more example.